Hello to everyone. Like here is this Rays and Victors, and today we're going to present our analyzing the air quantities data of Beijing's, and we're going to letting the machines to predicting the PM10 concentrations of this data sets. Okay, first we're going to have data descriptions. And our data is considered have 6 main air pollutants and 6 prevalent meteorological variables and multiple sites in Beijing. And it is published by Beijing Municipal Environmental Monitoring Centers.
So now I'm going to introduce our roadmap and our executive diagram and our process of doing the project. So first, we imported and extracted the data from UCI machine learning dataset as a CSV file. And then we set the labels and the features of our model from the dataset. We set the PM10 as our predictor and the others as variables to predict the PM10 concentration. Then we built a model. We used a linear regression model using neural networks as the computational tool to compute the coefficient. Then we evaluate the model through comparing the loss between the models. And finally, we test the model to compare the prediction of the model to the actual data and compare the graph to it.
This is the data set after we visualize it. And it shows the peer point between the 6 main air pollutants concentrations, which is the PM2.5, PM10, SO2, NO2, CO, and O3. And in this graph, it shows that they are mostly positive related to each other.
In this project, in order to predict the concentration of PM10 using the other variables, we use a linear regression model by methods of constructing a neural network to compute the coefficient. And since this dataset does not have presidential essays using some statistical way to analyze it, so we ourselves build 2 different models, one with a simple layer of neural network and the other with 3 layers of neural network to compute and compare the results obtained by the models.
This slide shows the plot graph of the arrows of the predictions. And here is 2 graphs. The first graph is the model with 1 layer of neurons. And the second graph is the model with 3 layers of neurons. They've been all tested 100 epochs, and we can clearly see the difference between them. The model with 1 layer of neurons, it has about 50 arrows after testing. However, the model with 3 layers of neurons, it only have about 15 arrows after 100 epochs, which clearly shows that the model with 3 layers of neurons is more accurate.
The 2 graphs on the left represents the degree of fitting of the prediction of the 2 models. So theoretically, the point with coordinates of actual data and prediction should be strictly lying on the line y equals to x. And obviously, we can see the first model does not perform quite well since the scatter plots mostly deviate from the straight line. And the second model seems quite powerful since it fits the line really well. So based on the fitting degree, we can also imply that the 2 additional layers could actually exert great effect on the accuracy, the final result in a relatively simple model. And the right up corner is our code for the model for testing. I'm going to conclude the results of our models. So the best model in our experiment performed about 18 laws on the test set with our average number of 108 and standard deviation of about 90 on our PM10 concentration. And it is almost 64% lower than the baseline model, which is 1 single layer linear regression model.
And here are several things that we would learn from this experience. First is our fixing bug is the long process that we're using the same code, but after we like putting our data set in it, it always have a lot of errors happening in our code. But fortunately, we can fix them, which like it show up our results. And also, when the model is relatively simple, adding additional layers will be like good ideas, and it can make the models a lot more accurate. Also, the last one is the most important one for us is to adjust the data carefully before using it, importing it. Because this is not the first data set that we try to use, and we found the first data set that we found it have a little bit error about in its attribute, which make our code going to be errors forever. And this is the end of our presentations.
Thank you for watching.